Hello everyone, this is the Pencrest High School AP Physics 1 video series. Video 2B, Graphical Vector Addition. Alright, so there are several vector operations that are used in physics. They involve the mathematical manipulation of vector quantities. The only ones we need to worry about for the time being are vector addition and subtraction. You can use a couple of different methods to add and subtract vectors. There's a graphical and a mathematical method. We're going to start with the graphical method, first qualitatively and then quantitatively. Very simply, graphical vector addition means putting a vector on the end of another vector and figuring out where the object ends up. This is the easiest to visualize with displacement vectors. The method does work for other types of vectors, velocities, acceleration, force, but we'll look at displacement to begin with. All right, for the sake of illustration, let's say an object moves 3 meters to the east. We'll call that vector A. And then it's going to move 4 meters to the north. We'll call that vector B. We want to know where the object ends up, or what its final displacement is. We'll call this resulting vector R. Common sense will tell you that it's not 7 meters away from where it started, even though it went 3 and then 4. So this effectively shows the graphical addition of vectors. We have vector A, we put vector B on the end of it so that the back end or the start of vector B is at the end of vector A. And then, assuming that the object started at the origin, okay, vector A starts at the origin and then B starts at the end of A. The result, okay, this method, by the way, is called the tip-to-tail method because you're putting the tail of one vector on the tip of another. Notice that the vector R, the result, starts at the origin and ends where vector B ends. What you see here is a common mistake people make when they add vectors. For some reason they do A and then B, and then for some reason they think R goes back to the origin from the end of B. It does not. So this is not what vector addition looks like. Look at another example. We have vectors C and D. We're going to say that the result equals C plus D. We start with vector C, and then we put the tail of vector D on the tip of vector C, draw vector D, and there's my result. Okay, this method is not limited to only 2 vectors. Let's say that we're going to have vector S, and that's equal to vectors C plus D plus E. We do it the same way. Okay, we put C first, put D on the end of C, put E on the end of D, and the result, S, is where the first vector began to where the third or the last vector ends. It's okay if the resulting vector crosses over the combined vectors. There's no problem there. All right. Now, subtracting vectors is just as easy as adding them. Let's go back to using A and B like we had before. We're going to do a vector R2 equals vector A minus vector B. So mathematically, we know that A minus B is the same thing as A plus negative B. So we want to think about what is meant by negative B in a vector sense. Negative B has the same magnitude as vector B, but it's in the opposite direction. So B points this way, negative B points the other way. In this case, B points to the north, negative B would point to the south. We add vectors A and negative B the same manner as we did before. Here's A, here's negative B, and this would be my vector R2. All right. Now we're going to look at quantitative addition of vectors graphically, involving actual magnitudes and angles and so on. We have an assignment that you're going to complete that deals with graphical addition of vectors. Instructions in the data that you're provided with. You have a series of vectors here, A, B, C, and D, and then 6 different vector operations that you're going to show graphically and report out an answer in standard vector notation. All right, we're going to do R1 here. We're going to do A plus B step by step, and we'll come up with an answer, and then you're going to do the other 5 before this assignment is due. So here is an XY plane that you're going to use to show your graphical vector addition. We have vectors A and B here. Again, we're told that R1 equals vector A plus vector B. So the first thing we're going to do is construct vector A physically right on the paper. Okay, we start by putting the protractor at the origin. We've done this already. Make sure that the origin of your protractor is at the origin of your XY plane. And then what we're going to do is measure the mathematical angle of vector A. Vector A is at 57 degrees mathematically. So we're going to look at our protractor, measure up to 57 degrees, which is here, and we're going to put a little mark at the edge of the protractor at 57 degrees. Take the protractor away and then draw a light line using your ruler from the origin through the mark that you made at 57 degrees. All right. Now, along this line, we're going to measure the magnitude of vector A, which is 5.8 centimeters. So I'm going to put my ruler so that the 0 is at the origin. I'm going to measure 5.8 centimeters along this line that I made before. I'm going to bold the section of the line that represents vector A, put an arrow on the end of it, and label it vector A so that I know which one I'm dealing with. I can also erase the other markings that were up here. So there's vector A, actual size, actual direction in my XY plane. Now I'm going to put vector B on the end of vector A. Okay, vector B is 4.6 centimeters at 184. So in order to measure 184 degrees, you'll recall that 184 degrees is in quadrant 3. So I need to flip the protractor over based on the fact that vector B is in quadrant 3. Basically, I'm going to measure 4 degrees down from this side of the protractor. Again, here's my 0 point on the end of vector A. I've got 180 plus 4, which gives me the 184 degrees for vector B. So I put a mark at the edge of the protractor again. That's at 184 degrees from the end of vector A. You take the protractor away and again draw a straight line using the ruler from the end of vector A through the mark I made at 184 degrees. Take the ruler and measure the magnitude of vector B along this line. The magnitude of vector B is 4.6 centimeters. I'm going to measure 4.6 centimeters along here. And again, I'm going to make that part bold, label it vector B, and then remove the other markings. So there effectively is A plus B. The end of vector B is where the object would be if it went this far at this angle, 5.8 centimeters at 57, and then 4.6 centimeters at 184. So this is where the object is. That point in the XY plane represents the end point of vector R1. So there it is. I'm going to draw it in, label it R1. We need this vector in standard vector notation, which means we need its magnitude and its direction. The magnitude can be measured directly. Using my ruler, I'm getting 5 centimeters. Right? And then to measure the direction, we take the protractor, put it back on the origin so that the 0 point is on the origin of the XY plane. If you need to extend R1 beyond its end, you can do that to measure the angle. Looks here based on the navigational or the mathematical set of axes, looks like it's 107 degrees. Okay, so my final answer for vector R1, 5.0 centimeters at 107 degrees. All right. Now, in the event that your operation involves a subtraction of a vector, recall that a negative vector is in the opposite direction. So you can, given a mathematical angle to make a vector negative, add or subtract 180 based on if it's in quadrants 1 or 2. You add 180. If it's in quadrants 3 or 4, you subtract 180 to make the vector negative, and then proceed in the same manner. All right. If you are multiplying a vector by some constant, like 2b, for example, remember that the constant only applies to the magnitude of the vector. So if vector b is 4.6 centimeters at 184, then 2b is 9.2 centimeters at the same angle, 184. All right. That should do it for graphical addition of vectors. Next round is mathematical addition of vectors, and I will see you then.